Alright, now we have discussed activating groups. Next, we are going to be discussing deactivating groups. Deactivating groups will all slow down a reaction. So they are trying to pull electron density away from the ring, and when the ring is trying to behave like a nucleophile, that is detrimental to doing an EAS reaction. So all deactivating groups slow down a reaction. However, we can't use a broad term on whether it's going to go ortho, meta, or para with deactivating groups. You have to assess them individually. So not all deactivating groups will have a specific position that they favor, and we'll cover that in this video and another video I make. So again, we have a nitro group. The nitro group is a deactivating group. I highly recommend that you take a look at that table in the book that tells you what type of deactivating groups there are. And we're trying to do a nitration of this nitrobenzene. And I give you the question again, is it going to be ortho, meta, or para? So the only way to do that is to assess the stability of your sigma complex for every position to see which position will be the most favored. To begin, let's do the resonance structures for ortho. And so we have three resonance structures. Let's do the resonance structures for meta. And one more time, three resonance structures for meta. Now lastly, let's do para. And again, three resonance structures. So three resonance structures for ortho, three for meta, three for para. We can't distinguish which one is more stable based off of the number of resonance structures. But there is information here that will tell us which position is more favored or is going to be the major product. When we take a look at the ortho and para, the positive charge lands on the carbon. So in this example here, the positive charge landed on the carbon that has the nitro group attached to it. And in this position on para resonance, again, the positive charge landed on the carbon with the nitro group attached. So you got to think about the nitro group itself. It is an electron withdrawing group, so it's trying to suck electrons out of the ring. And if one of the resonance structures has a positive charge on the carbon and it's trying to suck electron density away from a positive carbon or a carbocation, that's really unstable. So if we look at meta, meta doesn't have any situation where the positive charge lands on the carbon bearing the nitro group. With that said, meta is going to be our favored position for this nitro deactivating group. Most deactivating groups will be meta. I know I said at the start of the video that some of them are not, and you have to assess each one. So make sure you're always doing this assessing. Don't just assume. It's always good to keep doing all of these types of resonance structures to keep practicing and to make sure you don't miss something when you're assessing these molecules. The next video I'll make will go over a deactivating group that has a different major product. So I'll see you then.